Hi. This is an example that I have taken from the book. So problem number 15. So you could see it here. Here, problem number 15. Yeah. So that is problem 15. So what it says, one of these cars has got a dead battery. So in order to charge the battery, another car which has not got a dead battery, a live battery, so one of them is going to give the energy, the other one is going to take the energy, charging. Now how we do this, you're going to connect in parallel those two batteries of these cars. So the voltages for both cars is 12 volts. And the current that we measured, it says 30 ampere for this reference. So the question is, which car has the dead battery, blue one or the red one? So what we are going to do is this. For this, let's make it red. So considering this one, so this current pass goes from plus to minus like that, isn't it? So this is the same direction. So this current that we measure is 30 ohm. The voltage is I is 30 amps. Let's make it a better, you see, maybe the area is not so easy. So what I am saying that I is 30 amp. You see, it is a constant current, so there is no T involved here. And the voltage is V, according to that reference, that plus and that minus, is 12 volts. So if I multiply those two, I get the power. 30 times 12 is equal 3600 watts. Okay. Now this is for the red car. Let's come to this blue car, this one. So this is the voltage reference. According to passive sign convention, the current reference should be that way, isn't it? Not seen here. I'm going to throw it here, like from plus to minus, so like that. Okay. So plus to that one, so it is the opposite side, isn't it? So this current against to that. So blue current, if the current that we measured for this reference is 30 amp, for the opposite direction is going to be minus 30 amp. So so for the red one, I is minus 30 amp, and V is the same, isn't it? 12 volts. So when you do the multiplication, P becomes minus 36,200 watts. So since this is minus, that means this gives the energy. So delivers the energy, delivers energy. So this is giving the energy, this is absorbing the energy. So the red one is the dead battery. So I can tell you that this is dead battery. Why I said that? Because this consumes power. That means the electric power was not enough for this car. It had a bad battery. Now this energy comes from this car. So since the power is positive, then we say this consumes energy, absorbs energy. So this has got less energy and absorbs the energy from this car. That's why I said this has got the dead battery. So this car. And the other question is, say, if the connection is maintained for 1 minute, how much energy is transferred to the dead battery? Now we are dealing with energy, so we know definition of the energy is this integral 0 to t pt dt. That's the definition of energy. Now let's apply this now. So for that, this car, what is the energy? So P is a constant for the red one. P is the constant, that is. So that is constant, and it is 3600. Not 100, is it? I made a mistake. So this gives it 360. So in your daily life you might some mistakes like that. So I am correcting myself now. Delete this and delete this. Conclusion doesn't change, of course. Now that was the power that we have, and it is a constant, and multiplied with dt, and integral it 0 to 1 minute. So that's going to give me energy. So since this is constant, comes out 36 times t, and t is going to be 1 to 0, so 360, t is equal 1 minute. Now that to find it in joule units, 1 unit is 60 seconds, so I'm going to multiply it with 60. 60 seconds, 1 minute. So now that is 6 times 6, 36. 6 times 3, 18, 21, isn't it? 36, 3 carry, 18, 21, 6, okay, so it's like that. So that's joule, isn't it? So it is also means that 21.6 K joule. The conclusion is this. Now this car getting that amount of energy from this blue car. Okay, that is the answer to that question as well. That is the end of this. So let me clear this.